Linked to the can you hear us?
Yes, I can hear you. Thank you.
This is what I started. Yeah. I noticed.
Hello, good afternoon. I think we have to start. My name is Shirak Bata, and I work for International Livestock Research Institute, and I'm based in Nairobi. So I'm chairing the session. We have 5 presentations this afternoon on this session. 10 minutes presentation, and we have 5 minutes for question and answer. So it's time. Let's start with our first presentation. I'm with Oh, Kalkidan, okay. She's on. We check with Kalkidan. Okay.
India can chicken.
So Kalkidan, you can start.
Thank you. Good afternoon, everyone. I will just wait on for my slide to come up, if that's okay. I don't see it yet.
Chicken also share presentation. You can also share presentation. Can we share?
Okay. Kalkidan, are you going to share?
I can. I did send it as an upload, but I can also share my screen if you prefer that. Yeah? Okay. Good. I will be sharing my screen.
All right. So you have 10 minutes for presentation. All right.
Great. Good. I hope you see it just fine and you hear me just fine, just to get your confirmation.
Yeah, can you speak a little bit? Yeah. Can you please speak a little bit louder?
Okay. Yes. I'm also wearing my headset. Okay. Good afternoon, everyone. Thank you for having me on this session virtually. I apologize for not being there in person. My name is Kalkidan. I am a researcher at the Alliance Biodiversity in SIAD, based in Addis Ababa, Ethiopia. So I see a few Ethiopians in the room. Happy New Year, everyone. So I will be telling you a bit about the activity that we have under the Ethiopia Grass Project. I believe my colleague Anne will say a bit more about it later on. And in this presentation itself, I will tell you a bit about the exercise we're doing, engaging farmers as citizen scientists for selecting multi-purpose forages. This work is being done together with the Norwegian universities NMBU and NIBIO, as well as Ethiopian-based research institutes and universities such as Hawassa University and Bahar Dar University, and with a resource made available from the Research Council of Norway. So Ethiopia's economy is largely based on the agricultural sector, and much of the population itself, around 70%, relies on livestock rearing for their livelihoods and well-being. However, this large livestock resource that we have in Africa, it relies mainly on unsustainable feed system. So the feed is mainly sourced from unsustainably managed or poorly managed natural pastures. Thus, the sector is often related with land degradation and because of overgrazing, as well as having an impact on restoration efforts as well. And this is why when we started working on improved forages, we're trying to deliver multi-purpose forages. So those that can deliver quality feed as well as provide means to restore soil quality, soil health, and also reduce soil erosion and so. And this has been done in different projects, obviously, and different initiations. However, we've seen the gap that the uptake of it is limited, and we've taken the approach of engaging farmers in the identification of solutions, agricultural solutions. So for engaging farmers as citizen science, we've taken it as a good practice and have tried to do so in this project. And the idea is to identify which grass legume mixtures are performing well, considering different traits, and what are the main traits that are being preferred by farmers. So for this, having this in mind, the approach we took to engage farmers as citizen scientists is through the triadic comparison of technologies, often called as TRICOT. And with this approach, what we try to do is we randomize 3 different technologies, in this case, a mixture or monoculture of different grass legume mixtures. So we would have A, B, C, so 3 varieties or 3 species and their combinations provided to farmers, and they would evaluate the performances based on different traits, and that will be evaluated and will be ranked. So this is done under the ClimeMob platform. So you see some resources that have used this approach in different testing of new crop varieties. So the idea is that starting from randomization of these technologies to testing it on the ground, collecting data and analyzing data, this ClimeMob platform will be used. So our TRICOT sites are based in different agroecologies. So in northern and southern parts of Ethiopia. In the northern part, we are operating in the Amhara region, and in the southern part, we are operating in Sidama and Central Ethiopia regions. And in these parts, we are working with 600 plus farmers and in mixed farming systems. So they have both crops and have livestock in their production system as well. Yeah, and in this approach, we are also working with Warada level development agents. So Warada is one of the lowest administrative units in Ethiopia. And we have different development agents. We specifically work with agricultural development agents that delivers on extension services to farmers. So we're working with them with the identification of multi-purpose forage varieties and how we are planning to engage farmers, and they support the field preparation and the data collection in different trial phases as well. And these farmers are selected based on their familiarity to forage production and their engagement and potential to dairy production. So using the ClimeMob platform, we generate these barcodes that associate farmers to the type of mixture that they are provided with. So we have monoculture, but also the mixture of 2 or 4 species delivered to farmers. And these are planted in the backyard. They prepare 2x2 land, and in that they plant and monitor and respond on the performance of this species and their preferences as well. So you can see like some key traits that we are evaluating depending on the data collection session. So on germination or first harvest or second harvest, you would have this traits that we are evaluating, and the selections are quite simple in terms of like which was easier to sow versus which was more difficult to sow. So they'll be choosing only from 3 options. Yeah, and with that, we are analyzing different traits. So for instance, in terms of biomass or yield, considering Deisho as the most standard and reference species, then we could see that, for instance, the combination of Mombasa, Molatu, Desmodium, and Veg had the probability for outperforming both in the Amhara and southern regions. So in this case, we're categorizing Bosidama and Central Ethiopia as SNNP, as the previous region was. So then we can see that in terms of traits that they considered important, also in the overall preference, the fact that they the fact that they were easier to harvest or easier to transplant had more weight. So those traits were more correlated with the overall preference of farmers' selection of forages and their mixtures. Similarly, we were able also to identify and analyze what were the most important traits per each trial element. So, for instance, which species or mixtures were more related to a certain trait. So overall, we found the experience very insightful. For instance, even though we put on some traits to identify and rank species and their mixtures, we were also able to tell new things. For instance, farmers were commenting on the quality of the milk and the butter that they get after feeding a certain mixture. So this was also a new trait that we have found, and that it was much easier to scale. For instance, we had few peer-to-peer sessions, and farmers, the neighboring farmers were very excited to learn from their neighbors. It was much easier to scale, and they were asking for seeds because they saw their neighbor farmers benefiting more. So we know that there are also other biophysical and socioeconomic factors affecting both performance and preference. So we are also accounting for other socioeconomic factors as well. And in this case, we are doing the trials in backyards, but we are also considering doing the identification. For instance, if these mixtures are planted in restoration sites or in soil water conservation platforms as well as what are the environmental and socioeconomic impacts of replacing the traditional feed basket with these mixtures. And we have also been able to see that there are different enabling factors, such as the availability of forage seed and extension services that really impacts scaling and usability of the different varieties. If I have a minute, I would like to show you a video of one of our farmers. So I see that I have just a minute left, and that is also just a minute of a time, if that's okay.
Thanks, Kiran. We are almost on time, so we have few minutes for questions.
I'm not sure if you hear it, so if not, then we can skip this.
We have no sound.
There's no sound, it's muted.
And you probably can't understand that. It's always texted.
Yeah, I think there is no sound, so yeah, let's proceed to the question and answer. We have 2 minutes for question and answer.
Good, thank you. Then I'm done with my presentation. Thank you for your time. I'm ready to take questions.
No question, yeah? All right, thanks, Kalkina. Let's move to the next presentation. The presenter is Anna Roger. So you have it.
There is another microphone there. Hello, hello. 1, 2, 1, 2. I feel like I'm going to perform some music.
You can sing.
1, 2, 2, 2, 2. Maybe I just, oh no, for the people online,
Yeah, maybe.
maybe I use the,
But I hear you just fine, and
maybe like this is better.
Yeah.
Yes. So good afternoon, everyone. My presentation is actually a follow-up on Calcidans. So it's part of the same project. And you saw her somewhere mentioning as a next step, there should have been done an environmental assessment. So what I'm presenting is, no, it's not this presentation. This is still Calcidans. Mine looks green. So I'm presenting like a follow-up a quick environmental analysis of some of these farmer preferred grass legume mixtures that have been tested with like this wide range of farmers in Ethiopia. So my name is Anne Notemaert. I also work for the Alliance of Biodiversity and SIAD. We're working on the same project, and you see the other people involved. They're not here. Eyuel and Regasa and Solomon have been really instrumental in this analysis, but they're not here, so I'm presenting on people's behalf. So a little bit of the same context as Calcidan, but let's remind, Ethiopia really has a lot of problems with land degradation and erosion. Climate change is there and it's exacerbating the problem, while at the same time, livestock is actually really a big contributor to this climate change. It actually, from the agricultural sector, contributes about 70%, I think, of the greenhouse gas emissions in Ethiopia, and 60% of that comes from the livestock sector, so not to be ignored. But at the same time, this livestock is really crucial for livelihoods and the economy in Ethiopia. I've just listed some of the massive numbers there, 70 million cattle in Ethiopia. It's a big country too, but there is a lot of livestock there. So that's in that context, we actually designed this Ethiopia grass project. You've heard Calcidan talking about the actual really on-farm trials, but there were also some on-station trials. We did some greenhouse experiments. We kind of looked at the literature about the relation between forages and land restoration, and then I will present the cleaned modeling environmental co-benefits kind of quantification. So just a little bit more context about the livestock production in Ethiopia. We have, in very general terms, like 3 big different livestock production systems. The dominant one is really the mixed crop livestock systems, where farmers have relatively small pieces of land. Their main activity is crop production, but they do have livestock. And about 55 of the 70 million cattle actually are in that type of system. Then, of course, we also know the agro-pastoral system is the second important one, but quite a bit fewer animals in that system, and then very small proportion of more specialized dairy. So we actually focused on this mixed crop livestock system in the project. You saw on one of Calcidan's slides that the project was active in the north and in the south. In the south, we're in Bilatli district, where it's also easy still to operate. In the north, it was a little bit difficult the last time to get information, so that's why you also only see the Bilatli district information here. So a more or less typical crop livestock farm in that district has about 2 cows, milking cows, an adult male, 2 heifers or steers, and 2 calves. The cows are not very productive, about 325 liters per year, so very low productivity. But of course, the heifers and the calves grow. A quick overview of the feed baskets in the wet season and the dry season. So a lot of dependence actually on crop residues, mostly stover, maize stover, but also false banana leaves, sugarcane tops. Second, some grazing on natural grass. In the dry season, it's first converted into hay, but it's still that natural pasture. And then you have some cultivated forages, mostly desho grass, very popular in Ethiopia, and some napier grass. And in terms of how the manure is managed, it's mostly directed towards the false banana, and the maize gets some chemical fertilizer. Some information about the yields of these crops and their nutritional value. So all that information, we threw it into this iCleaned tool. It's a user-friendly ex-ante environmental footprint calculator. So the information I showed you on the first two slides is the main information you need to then calculate what I'm showing you here. So the total production in terms of liters of milk, but in fat protein corrected milk expressed here, how much manure is produced, and how much land is needed for the feed production. So it's about almost 1 hectare for the farm, and mostly coming from the crops because of the crop residue, the high proportion of crop residue. Then we can also see that in terms of nutrient management, improvements could be done, because most of the manure goes to the insect or the false banana. If we would kind of spread it towards maybe some of the forages or some of the other crops, we could get a better balance. And an estimation of the total greenhouse gas emissions associated with those livestock, those animals on the farm. A total of almost 6 tons of CO2 equivalent on that small farm, and in terms of per liter of milk, it's 7.5. So what our interest was, so that is the typical farm there, like what would happen now if those grass legume mixes that we've tried with the farmers, and they actually like them, they look at them and they're actually enthusiastic. It's really nice to interact with the farmers, and it's also for ourselves who work on forages, it's really nice to see those mixtures. They do very well. One of the ones that really scored high is this panicum grass mixed with brachiaria grass, and then desmodium and vetch. And in some farms, we started with stylo instead of vetch. But that's the one that we used as a scenario for integrating into the farm. We also had the on-station trials, and we really did see also that mixing those legumes and those grasses is not only better for the nutritional quality, because now we have a legume within the grass, so that speaks for itself, but we also did see kind of a yield gain. So each of these crops kind of really looks for their niche, and kind of then there's a slight benefit in total yield. So the scenario that we ran with the clean tool was replacing of 50% of the grasses in the feed basket. So the first one is just focused on the cultivated forage grasses, so that they show in a napier. And then in a slightly different scenario, we also replaced the natural grassland with some more cultivation of forages than on the farm. And this is what came out. So in gray is the baseline that I already showed you before. And then you can see that, so we did assume also that by improving the feed quality, the productivity of the animal, of the dairy animal, goes up by 5% with some small introduction of the legumes, and 10% with what they called here a lot of mixture. So you see, of course, the total milk production, the total, it's not meat, but live weight gain has gone up. But by introducing those mixtures, our need for land has gone down a little bit. And the greenhouse gas emissions have gone down a little bit. I mean, these not have gone down, would go down if the forages are really adopted. That's just some co-benefits that we hope to see by now in the next stage, really hoping to continue the project and work on the scaling of the grass legumes mixtures. So this was just kind of one district that we looked at. So we really want to do a wider assessment. What would this mean in different areas of Ethiopia? We also feel it's really important to do a cost-benefit analysis, because what drives farmers is often the economics. Are there some implications in terms of labor, maybe for the women? So some gender analysis, and then synthesize it all. And before the end of the year, we still have a big stakeholder meeting where we want to really disseminate and talk about the findings and decide together with stakeholders what are the next steps. I think that's what is whatever is on this slide, I've already said. So if we want some sustainable farming in Ethiopia, we need to change something, and grass legume mixes seem like an interesting option to explore further. Thank you for your attention.
Thanks, Anne. So now we have a few minutes again for questions. Any questions?
Thank you. That was quite interesting, and I'm very happy also with the reductions in the emission intensity. And I would also like to know what do you think, to what extent can you go in terms of reduction on intensity, because it still looks like 6.5 is still relatively high at the point where you are. And also legumes usually need a high pH soil. Do you face any challenges with the pH of the soil when you increase the proportion of legumes?
Okay, so we had a lot of problems with the stylosanthes somehow. It was really even struggling. We struggled to even establish it, so we went to. That's actually why we then moved to veg. But otherwise, they were actually performing very well, the mixtures. It was really nice to see as well on station. So we had on station at Hawassa University and at Bahindar University, and also at some kind of more remote sites, not only on the campus, but also there. So they did very well. And also our 600 farmers actually really also had good results with the mixtures. I guess we had also quite high potential areas in midland, good areas where we targeted the production. In terms of emission intensity, is very high, because you saw the productivity, 325 liters per year. That's extremely low. That's very low. And then the scenario I ran, I didn't want to overdo it, but what I could have done also is kind of run scenarios with different increases in productivity. Now I just kept it very kind of low. So you see a bit of increase, but I think we really need to get the productivity up. It's the bottom line is that for everything, also for the income of the farmers, for having more nutritious food for the children, which is a big issue in Ethiopia. I think that the bottom line is we need to increase productivity, and we will get very nice benefits in terms of greenhouse gas intensity.
One last question.
Yes, thank you. This is now. What would be ideas for increasing your productivity? Because if you then come in with other things that might distort your greenhouse gas emission balance again on the overall balance sheet. Now, establishing the grass legume is a fine thing, and will be positive in your greenhouse gas emission, but if you then come in with other things to come up from those 300 kilos or to whatever, that might counteract what you intend.
Yeah, I think of course, if we will get the genetic potential, getting bigger animals and get really up to much higher production, we will get for cow definitely more emissions, right?
Yeah.
But if we can get, I want to come, when I look at it, I want to come from the consumption side. So in the end, we want to produce a certain amount of nutritious food.
Emission per liter.
So it has to be emission per liter. So for me, the greenhouse gas emission intensity will always go down if you increase the productivity further, I believe.
Huh?
Yeah.
Okay, yeah, might be interesting to see.
Yeah, I've not seen any other scenario because most of your greenhouse gas emissions are associated with keeping your animal alive. And whatever you add in terms of productivity, that adds more greenhouse gas emissions, but it's a smaller proportion than the maintenance greenhouse gas emissions. So increasing the productivity per liter or per kilogram life weight is always improving efficiency.
Thanks, Anne. Let's move to the next
Thank you.
presentation. The next presenter is Dahla Nudin. So you have 10 minutes or so, 10 minutes. You can use the speaker, your microphone. Is it okay?
Yes, yes.
Okay, no, that's fine.
Okay, thank you. Good afternoon, everyone. My name is Dahla Nudin. I'm from the Ministry of Mataram in Indonesia, in Lombok. For those who've never been to Indonesia, Lombok is just half an hour flight from Bali. I'm here with one of the co-authors back there, Yusuf Ahya. So my talk today is about factors affecting sustainability of innovations by smallholders. This is from our experience working with smallholders cattle production for more than 20 years in Indonesia and Timor-Leste. I'm not going to talk about all the projects, but I would like to pick up a few projects with contrasting outcomes. After the project is finished. So the first project I'd like to talk about is what we call integrated village management system, in which we implemented several components of the innovation. Firstly is control mating using selected bulls to be able to have the cows giving birth or the calf born at the right time of the year, so we can reduce the calf mortality and increase the calf growth. The second component of this innovation is to remate the cows 40 days after calving. So we can have like 60 days empty, and so we can have approximately 12 months calving interval. Of course, in this innovation, we try to increase the quality of the diet by feeding us a lot of forages, like 3 legumes, and weaning calves at 6 months old. And lastly, so we increase the supply of the high quality forages like improved grass and legumes. The output of this project was quite good. As you can see here, that the calving rate increased to 87% almost, from only less than 60. Calf mortality reduced from 15% to only 4.9 or less than 5%. And most importantly, we increased the weaning weight from 70 to more than 90 kilograms, 6 months old. This is very good, but then after the project is finished, we went back to check whether they're still implementing the innovations, and we found out that only few components of the innovations being implemented by the farmers. The second project I'd like to pick up today is cattle fattening based on Sesbania glandiflora. This is a 3 legume, very popular in Southeast Asia, especially in our region in Lombok. This is a very good forage. It has a very high protein content, like 24%, 24 to 28%, very high in digestibility, and also it is multi-functions. We can use as a forage, even as vegetable, as you can see in the picture. And also we can use as timber or firewood. With this supplement to the diet of nut grass or any grasses we can find in the field, we can increase the live weight gain of the body cattle from 200 grams per day to more than 400 grams a day. So we can reach slaughter weight of about 300 kilograms at 24 months. This is very short, much shorter than when we feed them with full diet, which is within at least 66 months. As you can see here, the result is very good. But again, this innovation was very difficult to scale up because actually Sesbania requires a specific land type. It likes fertile soil, so we cannot move that to a dry area with sandy soils, for example. And the other thing, the small thing that prevent us from scaling this out is that the rice buns are not all protected from grazing animals, so we cannot grow this in wider area. The third project I'd like to talk about is the cattle farming based on complete diets. The base diet we use, basal that we use in this project was Lucina Lucosepala, because we thought a lot of farmers feeding just the Lucina, and we thought that's too much protein in it. So we put some cassava in it and mix with rice straw and some minerals. And as you can see, as we increase the amount of cassava to up to 45% in the diet, we can reach a very high growth rate of this small cattle. So you're not comparing this with Western cattle. This is very small cattle. The mature weight is about 300 kilograms. So we can have like 0.7 kilogram a day of growth rate, which is 3 or more times faster than when we feed only grass. Then, as you can expect, the outcome of this innovation is it is very challenging to scale out because cassava is also used for human food, and it's an extra cost to the farmers. Even though we increase the growth rate more than when we feed only the Lucina or Sesbania, but farmers cannot sustain this innovation because they don't want to spend extra money for that. The next one, what I'd like to talk more is about cattle farming based on Lucina Lucosepala. Lucina is so far the best tree legumes we think for the dry areas in the tropics because it can stand very long dry season. It doesn't require fertilizer. We don't have to irrigate. And most importantly, that it just like Sesbania, just like other tree legumes, increases the live weight gain of the cattle more than double, from 20 to 0.5 kilogram a day. And also improve the carcass percentage of the cattle of the bull from 48 to more than 52%, which is quite significant. And for the farmers, it is very important that it increases the net profit by almost 70% compared to the other feeding system. As I said before, it thrives well in dry areas. As you can see here, it used to be very dry, but in 3 years' time, we changed the microclimate into a very nice landscape, and we can have a good forage at the same time. And this is in line with what we are talking a lot these days, is about how to reduce the greenhouse emissions, because when we feed Lucina, there are two things can happen. First, we speed up the growth rate, so we can reach the slaughter weight at much shorter time. And also we reduce the methane emission. So I'd like to talk about this project because when we finished the project in 2022, I think, farmers are still planting it. Farmers are still using the Lucina for farming cattle. So this is very good outcome. And we estimated around 5,000 farmers in the region, in Indonesia and Timor Leste, are still using this for cattle fattening. So in short, we can point out factors concerning sustainable adoption of innovations. The first one is the innovations might be complicated for farmers because they don't want to apply very complicated things. They just want a very simple one, but effective. As happened with the cassava, it also might require extra costs, even though a small amount of money, but for farmers is very important. Once they want them to spend some money, then they might reject to implement the innovation. And I think most importantly, the factors that constrains the adoption is it lack of meaningful financial incentives. It means okay. And the other thing is that it competes with other programs that provide handouts. And the last slide I'd like to summarize is that the keys to sustainable adoption for this model. First one is, as I said, the innovation should be simple but effective. It creates meaningful financial incentives and doesn't need significant extra costs. And also it should be suitable for particular farming system and easy to implement. And lastly, it should be supported by government policy. Thank you.
Thank you very much. We have parties for question. Any question for?
Yeah, thank you very much for the presentation. I'm David Weisman from Guru University. I was seeing in one of the projects where you're getting mortality of 15%. That's really very high.
Yes.
Yeah. What could have been the cause and maybe what could be the ways of combating it? The second question is about Sesbania. For us, we have tried it, but palatability is actually very low because of, and it can fix actually calcium because of the oxalates. I don't know what your experience was. Thank you.
Yes, the crop mortality is very high in our region. Even in some of the other drier area in Timor Island, it can be as high as 30%. One of the reasons for this is, the calf was born in the peak of dry season, and the milk production is very low, and as a result, the calf might not be survived. So that's why the mortality is very high. And also, at the time of the calf is born, the score condition of the cow is very low, like 2.5 lower or lower. So that again, which was cause this as a very little milk in the cow. About the Sesbania, what we use here is the Sesbania granivora. So might be different from your Sesbania because to our experience, this Sesbania is very palatable. Even we can use this as vegetable. So must be different Sesbania what we have.
Question? Yeah, I have one question for you. So you say for beginner profitability, it increases the profitability of farmers. So how do you know that it's because of that field? It will be also price change or market dynamics.
Okay, that up to 70% increase in profitability was based on our economic and financial analysis. We compared farmers, a group of farmers feeding cattle, which is many only, only, compared to the other one feeding other feeds like mostly grasses. So we calculated all the costs and also the income from feeding. The difference will be around the growth rate of the one fed with grasses or other feeds are much lower. And the growth rate of the cattle fed looking at is much higher, like 2 or 3 times higher. So that's why the increase of the net income for our area. Thank you.
Thanks very much. So, the next presenter is Asa. Not that one. Not this one. Asa, not this one.
Yeah, the last one.
That last one. Thanks to you, it's my first.
Okay. Good afternoon. Yeah, I'm Asan Dambi from Wageningen University, and I would like to talk about the feasibility of using black soldier fly as an ingredient in feed production in Ethiopia. We've done it together with colleagues. Those who don't know black soldier fly, that's how it looks like. And what we use for feeding is the larva, and I'm going to show you also in future slides. Well, the context, there's an increasing population in East Africa. Ethiopia is one of those countries, and the demand for animal proteins is increasing, and this is posing a lot of pressure on land for producing soybean, but also overfishing to get fish meal to feed livestock. On the other side, there is a lot of waste being produced and inadequate ways of handling the waste. And another problem is depleting soils. So we need a lot of fertilizers or manure to replenish the soil. So I'm trying to look at a 3-in-1 solution to those problems. The black soldier fly can use waste to produce feed. At the same time, the byproduct frass is going to be used to restore the soil. So it will solve many problems in one. So our study was just looking at how feasible this is in the Ethiopian context. And we did interviews and also collected data, secondary data from different sources. And just to show how much waste is produced and how it has evolved, just see how much waste was produced in 2021 Addis Ababa, and in 2022 per capita it more than doubled. And this is the trend. The waste, the total waste and the per capita waste production is increasing in cities, and in all the cities in Ethiopia, you can see the same trend. And there's a lot of challenge managing this waste. And using BSF is a way of reusing the waste rather than dumping it into different sites. So one first thing we did, we looked at the cost, because we tried to look at if a smallholder wants to do his own BSF production, how much is it going to cost? And looking at the capital cost, is about 122,000 Ethiopian birr, and then total cost, including operational cost, is about 311. With an exchange rate of 125, we are somewhere around 2,500 euro to have a unit, a functional BSF unit. Now, when we look at the returns, we did two calculations here. The first calculation, we gave a price to the BSF, which is equal to fish meal. And in the second, we gave a price which is equal to the price of soybean meal. If we sell BSF at the price of soybean meal, we will have a loss with this system of production, with this cost. But if we sell it at the price of fish meal, we will get a profit. That means that BSF production in smallholder systems could give a loss if you want to compare it to soybean meal price. But of course, it's not just comparing, but you also compare the ingredients. But the farmer also looks more at prices, costs, and benefits. And that's why we did this comparison. Then we looked also at the enabling factors, what makes it work. So first thing, logistics. We think that it's important to look for a reliable source of organic fertilizer, especially waste companies, so that you can always produce. The legal process is also an issue, standardization, because the standards usually change with time. And the organic fertilizer was quite an important aspect because I mentioned depleting soils. So it's very, very important for them to use the frass, which is a byproduct, as a fertilizer. And the cultural aspects, with different interviews, we got more of rejection. Acceptance is not very much on the use of BSF, even as a feed, which is a bit different in Kenya. We did another study in Kenya and we saw that acceptance was quite high. Farmers, 76% of farmers were willing to produce BSF on their own and even use it to feed their own animals. And what they considered most was also the cost. If the cost of production was somehow manageable, and if the price of BSF in the market was comparable to other sources, then they would happily use BSF as a source of feed. So what drives the success of use of BSF? Availability, accessibility, and quality of waste streams, I mentioned. There's also the skill of production. There are a number of farms that stop operating because maybe they lose the starting material, because maybe temperatures go too high at some point and they lose everything. Then infrastructure, the construction of all the infrastructure with the greenhouse unit. And then the acceptance in Ethiopia is still an issue. Many people are not yet convinced that it's something, well, they still find it a kind of taboo. And of course, price competitiveness, I mentioned, it has to be cheap. It has to be cheaper than alternative protein sources. And just to finalize, last slide, recommendations. Ethiopia is still dependent on government kind of advice. So the government needs to step in and say, this is something nice and we recommend it, then people can adopt it. Otherwise, it is very difficult for people just to pick it up. And partnerships between those who collect waste and those who need to do the farms need to be built so that we can have a better management of it. And then we also need some scientific work also to help reduce the cost so that it becomes even more competitive. And yeah, demonstrations are good to improve on the technical know-how of the various producers so that they can also work successfully in producing BSF. Thank you. I hope I get it.
Thank you. Yeah.
Oh, it's like microphone.
Yeah, this one. Thank you very much. So, question here.
Asa, thank you very much for this. Asa, thank you very much for this talk and bringing us to an alternative production of animal feed fodder. Can you enlighten us a little bit more about the process, actually, how this is finally produced? I think you're collecting organic waste, and is there any kind of how long does it take, and what is how much is produced, and is there any kind of health issues attached? So is there kind of control that maybe pathogens are somehow play a role?
Okay, thank you. I was assuming, because BSF is already been presented in Lopunta for the last about 8 years, I was assuming that people already know. The production of BSF starts by collecting waste streams. It's also possible to use waste like manure, so chicken droppings and also cow dung. But most people prefer fruit waste or market waste because it also it has to ferment, and the fermentation is more friendly when you use fruits. But there's also a kind of combination between, there's a carbon-nitrogen ratio, which is better, optimal for producing BSF. So people try to also bring in different nitrogen components. So the BSF, once you have mixed the waste, you have to put the eggs or the larvae into the waste, then they eat, and then they become mature in about 10 to 15 days. You can already have mature larvae that are ready for harvest. And then, I don't know, or I can't show the slide. Then you can dry it and feed it, integrate it with other feed ingredients. You can crush it. If you have local chicken, you can feed it fresh to them. They can pick it and eat just like they eat other insects. So there are different ways of doing it. It has a bit more fat than many other protein ingredients. So sometimes you would need to extract the fat, but you can also incorporate it into meals at a smaller proportion so that you don't have a problem with the fat composition. Then the next question was on if there are any environmental or those kind of restrictions. In Europe, there are environmental restrictions. There are a lot of environmental restrictions on the substrate that is used to produce BSF. There are things you should not use. In Africa, East Africa, the restrictions are on the quality of the final product, not on the input. So you can use any substrate as long as the final product is fit for animal consumption.
It's interesting that you should say that, that in Africa there's no restriction on the input, because if somebody now engages in a business to produce black soldier flies and you would collect waste streams from everywhere, the leftover after he has produced the black soldier fly might be a highly toxic sort of conglomeration of things which he needs to deposit then somewhere. Wouldn't it be prudent to introduce restrictions also on the input side? And then what would be your suggestion for a metaflux chain after the soldier fly has been produced?
Okay, on the contrary, black soldier flies have been used to convert aflatoxin contaminated grains into feed, because the black soldier fly that comes from it doesn't have the aflatoxin, and the byproduct, which is the frass, also is not dangerous because it is used as a fertilizer, as an organic fertilizer. And there are companies that are researching on fortifying it, increasing the nitrogen content with vermicomposting to produce a kind of marketable organic fertilizer from this byproduct. So I see it rather on the side of converting some contaminated feed to less contaminated than the other way around.
Yeah, I had a similar question, I think, as you had. I'm not familiar with, is, in your system, is it the farmer that is creating the flies, or is there an intermediate company, like you suggest maybe, who is mass producing the soldier flies? Because how do you coordinate the life cycle of your fly with the life cycle of your chicken production, and how does one of these productions generate sufficient flies to keep your 10 or 100 chicken alive? I'm not, it's just my ignorance, but yeah, would like to know.
Yeah, well, the farmer, it's possible for a farmer to produce the fly and to go through the cycle on their own, but because of too much fluctuations in temperature, a few of them lose their colony at some time of the year because they can't manage it. So what is now being proposed as an option is a kind of outgrower model where there is a lead farmer who is mainly producing eggs and supplying to farmers. And then the farmers, they take them from egg to larva, and then they can feed the larva to their farms. And because you need it continuously, then you can do it many times in a week, so that you keep, because the larvae, even when you bring them up together, some are bigger and others are smaller. So you can harvest the biggest ones earlier, and then you let the rest grow bigger. So if you are doing 2 times a week input, you might be able to have something to feed your animals daily.
So,
Keep your adults alive also, and the continuous production of eggs. Of these flies.
Yeah, if you are doing the whole cycle.
Yeah, exactly.
Yeah, but if you are taking from someone, you can take twice a week.
Yeah.
Yeah.
so we still have 1 minute, maybe I can also ask.
Yeah.
So you showed several factors that affect adoption or sustainability of this PCF.
Yeah.
And then you showed also if they get the price of soybean cake, then they lose, right?
Yeah.
So if there is no demand, I mean, because of these factors that you have mentioned, culture and so on. So how do you expect them they will get the good price for it?
Okay, well, the first thing is that the farmers, the commercial farmers, they are willing to use black soldier fly, and they use a lot of feed. So on the side of the market, from the commercial farmers, there won't be a problem. And now looking at the comparison, soybean meal is an animal, so it's a plant source protein, and the amino acids in soybean meal are different from the amino acids in fish meal. Fish meal provides more amino acids, better amino acids for growth, especially of chicken. So a chicken farmer could also consider it as a replacement for fish meal. So I think that if it starts off now, there will be time for people to get convinced, but there are already people who can use it. The commercial farmers can already start using it as others get sensitized and pick it up.
All right. So we have the last presentation, and that's I'm presenting on behalf of my colleague Asmasu. So yeah, we have the I'm going to check. This is on.
You want to take your time?
Yeah. I'm not going to check. Okay, right, yeah, please do so. Yeah. So my presentation is a bit different from the previous ones. This is more of modeling or the economic modeling. So here we try to explore mortality rate shocks, its effects in integrated livestock model. So this is just introduction, but modeling, detailed modeling of the livestock sector is very important. So there's been different models that have been used in livestock sector. Some of the models are more on livestock and they are not much connected to the economic models, but they have a lot of details. And then you have also economic models, and then they fail also to really understand the dynamics of livestock. Here we try to see what is the advantage of this modeling and then how we can also link that. So one of the livestock models that we also use is the dynamic model, and then this takes into consideration the dynamics of livestock. It takes into consideration like the different species, and then it disaggregates by age, sex, and size, so that to capture the production and also the feed requirement, and see also how the other factors like breeding and animal health also affect the production. So this is a very detailed, but it has also some issues because this is more of a livestock model and it assumes that the price is constant, which is not really true unlike in economic models. So when you really do this kind of analysis, you see that the productivity is just increasing and also the income. When you do some intervention, just because of the price issue, it's really assuming constant price. And the other thing is this is the global economic models or the sector models, economic models. So these are also they have their own advantage. There's a possibility to also incorporate crop in these models. But when it comes to livestock, it lacks also some details. What the advantage of the previous one, the health dynamics, it has a lot of details. You cannot see that in economic models. So economic models, they just aggregate the commodities of livestock, but they don't really understand what's going on behind. So that's also the problem with the sector model. So now, these are the advantages and constraints of the two models. So what we did here is now, what if we link these two? We will take the advantage of more detailed model of the livestock sector, and then you have also more model that takes into consideration the economic assumption very well, and also you have the possibility also to analyze trade, for example. In economic models, they show you some information around import-export, for example. Once you have production, what will happen to the excess if they export to the market, and also how you meet demand, for example, by importing livestock commodities. But you cannot do that in the other one. So linking these two will give you more understanding of the sector. Yeah, so this has been, it's been done also previously in insurance model. So we try now here to link these two models. So we use Tanzania livestock sector as an example here. So what our scenario here is, we try to increase mortality so that to see like what will change in the supply. So we call it supply shock. And then we try to see now how this increases the productivity or decreases productivity and income. So now in more detail, what we did was that we try to increase 70% of mortality. And so this is an increase of the business as well from 8 to 13.6. So we try to see mid-supply shocks because there will be a reduction in offtake, and then there will be less supply that will come to the market. And what does this mean? So this is the linkage. So in the diamond model, the health dynamics model, it gives supply to the economic model, and then the economic model provides price, because this assumes constant price, but they can include the price. You can capture the real price. So it gives information to the diamond, and then the diamond provides supply that accounts price change. Yeah? So now we've included animal mortality as a supply shock, and which means we'll have less supply. So that goes to the economic model, which also affects the price. Now, when price comes into the diamond, what will happen? So this is the pre-linkage result. So the income, because of the price, constant price, when you do certain intervention, it's just a straightforward. And then this is from the diamond model because it assumes constant price. And then, but if you see the economic model or the sector model, this is pre-linkage. You can see some fluctuation because price is not always constant. And then the income from the livestock commodities also, it's not really a straight line, but it increases there is a little bit of fluctuation. So this is the offtake. When you introduce supply shock, means you see the offtake is reducing. So what does this mean now in our models? So now once we link the two models, so this is the supply of meat in the herd dynamics model. So you can see the pre-linkage, it just assumes the income is straightforward, but now because the shock was introduced in 2021, you can see that there is a reduction, but then there is still, it continues straightforward. So, but in this economic model, you can see that there is shock, still there is a reduction in after we do the linkage in terms of supply of meat, then it increases. So, but this supply increase and decrease, how does this affect also the price? So now, because of the shock, the supply will reduce, and then even, but they extend in like the price, how the price affects because of this shock. It depends also on the gap between supply and demand. So here, what we try to do is how will be the economic, not the equilibrium supply and demand. Is it going to reduce, or to what extent is it going to reduce? Because now you have less supply, so at some point you have the demand and supply equilibrium. So because now you have less supply, and then that equilibrium will go down. So we try to see the percentage of change. So if you have a big change, then that will affect really the price. Yeah. So now this is the price of meat after the pre-linkage and post-linkage. So here, because of the gap, which is there is less supply in the market, the price increases. And then this one, the post-linkage, also takes into consideration the change between supply and demand. So this has effect also on the income. So maybe let's show the last. So this is the income from the previous model. For example, this is pre-linkage, which assumes this straight line, but when we link it, it takes into consideration the gap between supply and demand. So let me move to the set. Yeah. So this is on the economic model again. So the demand is high and then the supply is very low, so there is increase in price, but there is variation also when the economic model is not linked to livestock model, and when the economic model also linked to the livestock model. So the conclusion is, if we really want to inform what has happened in terms of the market of livestock commodities, we really need to take into consideration the details of livestock in economic modeling. But most of these economic modeling that are existing, the partial equilibrium model of these CG models, they don't really take into consideration the details of livestock. So here what we try to show is it's very important, it is there, it's only that it's not taking into consideration some of the economic assumption. So, but if you link it up with economic models, then you can have a result that can really understand also the livestock sector, because livestock is not the same as crop. Because to incorporate crop in the modeling is not that much difficult, but for livestock you have a lot of dynamics. So now how do you incorporate these dynamics in this model? So that's it. Thank you very much. Hope I'm on time for
Yeah. Good. 11 minutes.
Great.
One extra.
So we have time for.
Thinking about the question. Okay, thank you for this modeling overview. I'm always thinking of when I listen to modelers, how close it comes to the real what we experience in the real life. So if you have validated the model with some more data from the past, where these kind of shocks have really happened, and can your model then predict actually what was happening, so that you can validate your model? Did you do that?
Yeah.
For me, it was quite abstract.
Yeah. Now, I can also give an example. If you don't really take into consideration the complexity, let's say in this case, livestock, you just use only the economic model, your result might not really reflect what's in reality, because you are now using only some prices, existing price data, and then the production that you get it from secondary data. But you are not really understanding the details on the sector. For example, you have like animal health issues, for example, the mortality, the disease, and so on. The type of breed that you have and the feed that, like they been explaining, those all plays role in that production. So the way production is calculated in the secondary data might not really reflect your analysis or your foresight analysis. So, but if you take into consideration the details of livestock and then link it up with the economic model, that's maybe you can get something that's really reflects the reality. So there is impact model. It's developed by IFPRI. It's a global model, for example. Using that model, they advise policymakers in World Bank or in FAO and so on. But they work with also what they have noticed is also reflects some details in that. Because livestock is there as just as communities, but there's no, the model doesn't understand also the details. So now we are working to do the same way, like to link it to a livestock model so that we can come to something, analysis or output.
Yeah. Yes, maybe I'll try. You have assumed that a shock to the livestock sector, or you have modeled that with a 70% increase in mortality. First of all, I would like to know what is your basic mortality. You said is 8%, and how was your usual offtake from the livestock population? You had said that then in decreases, the increased mortality decreases also the offtake. And you're referring to the whole Tanzanian livestock sector. What would be the offtake in percent of the national livestock herd? And is it really such a linear thing? You have one shot, mortality 70% increased, offtake so much less, and then the production continues. If I look at the lines, more or less the same way. There's not some sort of tail effect or again pickup effect. How is that reflected in your dynamo model there?
That's a good question. So for Tanzania, we have done this analysis in 2017 to support and develop their livestock strategy. At that time, we have used only the diamond model. So like I have said, it doesn't really take into consideration the price change. It just assumes constant. And then if it's constant, your income will be also constant when you do the analysis. So from what we did, we tried to show them, for example, if they do some intervention on animals or breeding or feed, what will improve? Because the objective was to prepare their investment plan in the sector. So our data shows that, for example, if the mortality decreases, it will affect also the offering. So that's the data that we have. So now we tested that also in this linkage of these models to make sure that if this works also when we link, it's just a testing case. Yeah. So we can do also this with other scenarios. Like for example, if you have, let's say, feed type of scenario, feeding the animals into feed, then how will that translate to supply? And then when you have also the price comes in part of the chain. You can do the same for breeding, but this is going to be a long-term impact. So that's why we do this linkage.
And how high is your offtake normally?
I can't really remember because it's been some time. Yeah, but what we've seen is like we have done with business as usual and with interpretation type of scenario. So the main idea is to increase their offtake and support them to increase their offtake and then get income out of it. So when we compare the business as usual and with intervention, there was still gap. That's why we have used that as a scenario, but I cannot really remember the exact figure.
I still have a little bit of question that you also have sort of, if it has been validated. I mean, I can imagine, for example, I've been working in Mozambique, there has been a drought many years ago or flooding, whether you can collect data from such an event and then see if your model indeed is giving you the same results. So a kind of on-ground validation, maybe on a much smaller scale than just an entire country. But say if you, I don't know whether it also works for African swine fever or something like that, you have these outbreaks, would it be possible to validate it and see what happens if you have an outbreak, say in Rwanda or a part of Rwanda, what happens?
Yeah. Thanks. So in terms of data validation, there could be data available secondary data. So most of the time we don't really use those secondary data. We validate it also with some experts from the country. So there could be, the parameters that you find them in secondary data might not reflect the reality. So you make sure that this data are validated to use it in your model. So once you are okay with your data, and then you can do some scenario analysis. For example, you say there is outbreak of this, right? And then that translates to mortality.
Yeah, I understand, but I don't see when you consider the data that you put in the model are validated. I think that is what I don't.
Yeah, so
understand.
when there is outbreak of this, then the data that we collect also reflect somehow, right? In your production and then also number of animals and so on. So you have to use those data to see the impact, yeah? Otherwise,
No, exactly.
yeah.
But I think the question was whether that had been done or not.
Yeah, there was no such case, but we try to consider also, animal these issues. All right.
Yeah, thanks very much. The way I understood your presentation is that the modeling is based on mortality. Yeah, but and if mortality is going to affect the offtake, I don't know whether the offtake was defined in terms of the numbers that can be extracted on the amount of mass that can be extracted from the existing population. And if it is numbers, I think it is quite misleading because if you are going to compute maybe the economic streams out of the offtake, you have to consider the mass. And that mass can be affected by mobility rather than mortality. And mobility can be actually influenced by other conditions other than death. So maybe the model should be really kind of validated in terms of mobility losses rather than mortality per se. Yeah.
I understand, but this, like I said, this is just an example. Whether we can do this linkage of data models with economic models. What we try to see is like, there will be some change in supply. It could be animals or change in supply, right? So how does that affect the market? Will that increase the price? Or how is it related to demand? That's what we want to show here, because the livestock model doesn't show us that one. But now once we link these models, we are able to see. So that's the main message from this thinking. But I agree with you, if you want to do some other things, you have to really go get good data, and then you have to make your assumptions also correct. I think we are already beyond them. So yeah, thanks very much. That's it for this session. Thanks. Thank you.